Let's record. Recording in progress. All right, welcome everybody to Shading and Lighting. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 11. And I got 1, 2, 3. Okay, we're missing a few people, but we will soldier on here. All right, so for the people on campus, just make sure, please, you maintain 3 feet of distance while we're in the room. In fact, it's a good idea in any indoor locations, keep 3 feet away. Go outside, yep, you can take your mask off. Be cautious though, not everybody's been vaccinated. If you haven't been vaccinated, I encourage you to do it if you can. Like I said, please wear masks at all times, indoors, in full sail, especially in class. Now, if you have to get a drink, that's fine. Take it off real quick, get a drink, put it back on, please. Water is perfectly fine as long as it is, capped in some way. So if it falls over, it doesn't leak out. And if you are sick, please don't come to campus. Stay home. We can deal with that. I can give you virtual attendance. I'd much rather do that than have somebody get sick. All right, 1 second here. I got somebody in the waiting room and I don't recognize the last name. So once they tell me who they are and I make sure they belong in class, I can let them in.
Professor, if you don't let them in, how will they see the thread?
Because I can type to the people in the waiting room inside Zoom. So right now it's waiting room and you can see down here at the bottom, it says everyone in waiting room. So I just sent them a message. Hopefully they are looking at Zoom so they can see the message. All right. Oh yeah. Also, when you guys come in, it's a good idea. I've got some spray bottles up here filled with alcohol. It's always a good idea. Spray down your station real quick just before you put your stuff out. When you're done, please, after you pack up, spray it down one more time just for the next person coming in. Make sense? Thank you. All right, so if anybody has any questions about, safety concerns or anything, let me know. All right, so welcome to Shading and Lighting. Our class is broken up into 3 parts. Not actually 4 parts, I lied. All right. Part 1 is rendering. Rendering is pretty much the foundation. If you want something to look finished or polished, yes. Oh, sorry. There we go. Is that better? All right. Sorry about that. All right. So first part, my screen was frozen. So first part is rendering, which we're going to be doing today. This sets the foundation for everything, because if you can't render or get a final output, what good is all the great work you guys do? You want to make it presentable to either a prospective employer or in general, just to make it look good for whoever you want to show it off to. Third part, we get into lighting. We're going to start that in lecture 2. Part 3, we deal with materials. Do not confuse materials with textures, and do not confuse materials with substance materials, because substance materials automatically give you maps. Anytime you plug something into a material, that is a map. And we don't get to maps until texturing. We have our 4 basic maps that we use, which is a base color. We use a spec map, we use a roughness map, and we also use bump map. Now, in substance, a lot of times you guys are probably used to the metallic roughness workflow. We use spec instead of metallic. Although we do use metallic when we get to metal, it's a very specific usage. So I don't want to say never, but we do get to doing that. And also in substance, you're probably used to normal maps. Well, we're going to use bump maps because they are simpler and they line up with the way all the other maps work for us, which are basically lots of black and white information that control different parts of the material. All right, so download project1_SAL_Arnold. And we will be also utilizing the Arnold rendering workflow doc, which is inside the lesson activity. There are links inside the lesson activity for pretty much everything you need. There are reading links. There are links to our YouTube playlist, which will include, for the most part, the campus lectures. We have a few other, kind of random videos once in a while in there. But lectures, since everything changes so fast every month, this is the best way for us to get new material to you, is in the lecture format. Because then we don't have to try and make a video for something specific that's going to be outdated next month when Maya or Arnold decides to update, or Substance decides to update. Like over the last month and a half, Substance did away with their Substance launcher and everything is on Adobe now. So little bit different workflow, a little bit different look. But the Arnold rendering workflow doc is basically a PDF that's updated every month, or every time something happens, I update it. And that way, when you click on the link, you are getting the most current information. If anybody has any questions at any time, please let me know. All right, so let's clear this off. All right, so as I said, my name's Tony Saxon. My email is on FSO, tsaxon@fullsail.com. Also, asaxon@fullsail.edu. I don't know why they changed it, but they did. Either one, it all goes to the same address. So this is the one I've had forever. I'm a creature of habit. But whatever you click on in FSO, if there's a link there, it'll take you to the right place. All right, so today lab will probably start around 6 o'clock because we'll get done around 5. We'll take an hour for lunch and then come back in, and you'll meet your lab instructors, Frank and Ari. They will be helping guide you guys through all the lessons throughout the month. We're going to do a lot of theory in lecture, and also when I demo, I'm going to be showing you specifically things you need to look out for when you work on your project. All right, I will have office hours in Discord. Our Discord server can be reached by going here. This will take you to Discord. You basically sign in with your credentials. If you don't have an account, make one. You will, when you first join our server, wind up in what we call the landing page, which is basically you're supposed to read all the rules and regulations for our Discord server. And then once you've changed your nickname, and I've included that information in the welcome email and in the welcome announcement, and it's also in the Discord landing page. It'll basically, we will manually have to update your profile so you can come in. So it's not automatic, just have patience. So I will have Discord office hours Tuesdays and Thursdays, basically from 10 to 4 p.m. Eastern Standard Time. We also offer an optional Zoom open lab that's available to you guys if you can take advantage of it or need it. It's also open to online students. So we can do a lot of sharing in Discord. Discord's great. We can do audio, we can do screen sharing. But if we get a bunch of people together, it doesn't always work out really well for screen shares. Zoom is much more robust and a lot better at it. All right, Sheldon. Let's see, Sheldon. Let me pause this. Let me check. So I have everything paused for you guys so I can check my roster and see attendance here. Ah, there's Sheldon. Hello, Sheldon, welcome. Sheldon, do you have an accommodation so you can do this remotely? Because if not, you're supposed to be on campus. All right, so what I will do is give you virtual attendance today. Unless you have an accommodation, you need to be here for lab, which starts at 6 o'clock. So if you need one, you got to fill it out. I sent you a link. Please take care of that. Okay. So sorry about that, everybody. We just got to do a little housekeeping here. So we were talking about Zoom. We were talking about our open lab. And like I said, this is open and optional for all students, online and campus. Like I said, we can do some sharing in Discord. Works pretty well, but Zoom is a lot more robust. All right, so as I mentioned, in campus, make sure you maintain 3 feet of social distancing in the room at all times. Make sure you wear your mask all the time indoors, especially in class. Like I said, if you need to take a drink, great, pop it off real quick, take a drink, put it back on. Make sure it covers your face. We have spray bottles with 70% isopropyl alcohol up here on the table. So I highly recommend before you put your stuff down, give it a quick spray. When you're done, pick your stuff up, pack it up, and give it another quick spray just for the next person. And if you are sick, you must not come to campus, please. All right, so expectations, we have 11 lectures, 11 labs. We have 7 main assignments. They are basically our lab assignments. They are projects. They are taking the topics that we talk about in a lecture or multiple lectures, and that information then you guys demonstrate in the project. So basically about rendering, about lighting, and of course with lighting, we're already assuming you can render. With materials, where you're going to have your stuff lit already, and then we're going to be adding materials and then texturing. So everything builds on everything else. We've also got 4 topical discussions and a research discussion. So if you have any questions about that stuff, let me know. We also have 10% GPS, and that rounds it up to 100%. All right, campus students, lecture is going to begin on the hour. If you're late to the live lecture or the Zoom, it's your responsibility to make sure that you let me know so I can give you attendance. If you're late, it's your responsibility to watch the lecture archives to get any material you missed. So as I mentioned, in September, all lectures and labs are offered on campus, and students are required to attend lectures and labs in person unless you have an accommodation in place. That means you have filled out the form that I sent a link for. And it's also the same form that's in Full Sail 1 for, they call it synchronous learning, meaning we're doing campus and we're also doing Zoom for those that need to. What is the time if we come in late and are considered to be tardy? That would be 15 minutes past the time. So there's like a 15-minute buffer. And then after that, we're supposed to, give you 2 hours out. But, in the beginning, everybody's finding their way around campus. We'll probably be lenient for the first week, but the registrars have told us that we need to crack down on it. So like I said, if you come in tardy and I missed you in the first attendance, make sure you come see me so I can give you credit for it. So tardy is not the same thing as being out for 2 hours. And our attendance policy prior to the pandemic was, you were allowed to be out so many hours in a class, no more than 10% of the class. Our class is 88 hours. And if you're out more than 8 hours of class, you will fail for attendance. I think that's still the policy that's going on, although we've been pretty laxed about it since pandemic and trying to reopen the campus. But go under the assumption that, yes, that is the case. Always assume the worst and hope for the best. All right, check your messages, please. Make sure you check them often. In fact, you should probably have FSO running all the time when you're doing schoolwork. Respond to messages, emails in a timely, professional manner. Don't use text abbreviations. Always start with a greeting. Please use capitals at the beginning of a sentence, and at the end of a sentence, put a period. You would never want to send a message like this to Blizzard or Disney or Pixar or Epic about, with poor grammar. All right, one request, don't send me any emails with attachments, put it in an FSO message and send me any files you need me to have or see. My email tends to quarantine files with attachments. Lately, they've been getting through, but every once in a while, I still get stuff that's quarantined and I don't see it for a week or two. In campus, no headphones or earbuds during lecture, please. Make sure you have them off unless you need them for, hearing purposes for lecture or lab. Oh yeah, phones on silent. I always forget that. Because there's nothing worse than having your phone go off right in the middle of something. All right, we are very technical. Not to scare you, but we are much more technical than some of your other classes. Probably right up there with animation, although we do have a lot more to worry about than animation. Animation, you pretty much live in the graph editor, and that's where you're at for the most part. For us, we're kind of all over the place. We've got switches and settings, sliders. We've got different windows to work in. We've got the render view. We've got the hypershade. We've got the viewport. And, well, also the render settings. So please take notes. Any actions, mistakes, issues, let's take care of them right away. There's nothing worse than having something just kind of sit around on the burner and not getting taken care of. I'm a big fan of, if something needs to be addressed, address it now. Don't wait for it. If you procrastinate, it usually makes stuff worse. If you have a problem with Maya, delivering your work, own it, see it through to completion. Ask for help after you've tried to help yourself. A lot of times, you know, on Discord, I will see students helping each other, which is really why we have Discord going on, to encourage everybody to help everybody else. And as far as troubleshooting goes, no matter how good of an artist you are, you will still be hired in some capacity for your troubleshooting skills. Everybody wants to know that you are not just a single kind of one, I was going to say one trick pony, yeah, but it sounds dated, but I'm glad you said it. Yeah, it's going to be, you know, you want to be able to show that you can do a lot more. And not necessarily be a generalist in everything, but if you don't know how to do something, you guys have the whole like planet on your laptop and in your phone. So you can always look up stuff. You know, we're always looking up stuff on YouTube and, you know, how to do stuff. You'll find instructions for almost everything, whether it's good or bad, on the internet. So when you are helping others, make sure you use empathy and understanding when you engage people with their differences. You know, it's not all about everybody's got to think the same way. Everybody's got different opinions, different points of view, different facets to the, we're all facets of the diamond, where we come and we all look at things slightly differently. It's not right or wrong, it's just different. Learn patience. Nothing happens as fast as we want it, especially in rendering. That is the key, patience. Learning can be difficult. Now, learning is difficult. Learning is difficult, especially with something new. Stick with it. Sometimes the path of most resistance can be the most rewarding when you finally crack the code. You finally go, ah. It's painful sometimes, you know, you reach those plateaus, you don't feel like you're learning anything, you make another little step, you feel like you're getting better. It just takes time. Sorry, I missed this, Haley. You said something about what if the email is with the accommodation letter we have from student success. That generally doesn't tell me, Haley, that you have an accommodation for the synchronous remote learning. So I need that to be specified if that is what the letter is for. Does that make sense? Okay, yeah. Because there are other kinds of accommodations, and I need to know what the accommodation is for. Like how it's being used. Because some accommodations will say you get extra time. Other accommodations will say you can learn remotely. So it depends on what is in the email or the letter itself. So if it's already in there, just send me a message. I'll go back and look at it. All right. So if you send an email, most of you will probably send messages in FSO, but if you send an email, make sure you use this proper email subject heading format, which is basically our class, which is right here. This is the month or term. And then this is the section. It's always 00 if you are campus. And then whatever the issues are that you're having. This way we know exactly, are you campus? Are you online? Where are you? And what is the problem? Because there's nothing worse than me getting an email with no heading. I don't know who it is. And a lot of times if you send me an email, it's from an outside source and I'll get a Gmail account that has nothing to do with somebody's name and I don't know who it is. So just assume that, your name is not going to go through. And also please sign it at the end so I know where you're at. All right. So in the lecture room, no food or drink. However, like I said, water is fine, especially if you've got a container like this, where you can turn it upside down, or you've got a capped bottle of water, that is totally fine. Just keep it capped, keep it closed when you are not drinking. Please participate, ask questions anytime. If you don't ask questions, I will just assume everything's good and I'll just continue on my way. Please do not share files or work with anyone else, and do not use someone else's work as your own, please. I have to mention this because it does happen. If you have any questions as to whether something constitutes an academic integrity violation, ask. It's much better to find out ahead of time. Use of profanity can be counted against you, not because I'm a prude, but because there's this thing called situational awareness, where there is a time and a place for everything. Colorful metaphors is one of them, but not necessarily when your boss is bringing clients through the office to go see where everybody works. And you're dealing with Maya crashing for the 20th time, and you drop all kinds of words that maybe they've never heard before. They think you're speaking in tongues, but, just makes for an awkward situation. And potentially job ending, depending on who's around. Any issues, bring them to my attention. If I'm not here and you're in lab, bring it to Frank or Ari's attention, and we will try to figure out what's going on. Repeating students, you must submit all new and different work. Some of the assignments have been changed from even last month. So make sure you are downloading completely new stuff. Any questions? Ask me. And as I said, all new and different work, that means if you've done selection A and there's 2 selections, do selection B. Or if there's 4 of them, pick one that you haven't done. All right, information is all in FSO. The Zoom campus lecture schedule link, ebooks, O'Reilly books online, our playlists, activity instructions, delivery information, and also downloads. So if we go back here, there's an overview. Here's the reading, all the links. This is Arnold's stuff that's all related. The meeting schedule is in our activity 4 under course overview. Discord, campus lecture, archive. So if you click on it, it'll take you to our YouTube channel. The latest lectures wind up at the top of the list. So if you want to watch something again, feel free to do that. Also for today, got a link to a short video from Disney about, it's called The Practical Guide to Path Tracing, which is what we use. Arnold is a path tracer. RenderMan's a path tracer. V-Ray's a path tracer. Unreal has path tracing in it. It is really a much more advanced way of rendering than just straight ahead ray tracing. All right, Algorithmic's website, that'll take you actually to Adobe's website. Here is our Arnold rendering workflow doc. Click on it, should take you into our OneDrive. So break down the Arnold render view, the render settings, and the rendering workflow, which is probably going to be, this is going to be how we do this all the time. So it's really meant to be a resource after you go through lecture 1. So instructions, we're going to be rendering a day scene, one of them, one night scene, and then you guys are going to take a crack at creating your own composition using the geometry we give you to basically achieve what's known as a layout. You're basically looking to get the look and feel of the reference that you find, but not necessarily be able to have all the geometry. It's not modeling. We're not lighting. This is all just about composition and rendering. We'll get into that in a little bit. So requirements, how we grade, what the deliverable package that you give to us looks like, and here's your download. All right, so lecture format, we're going to go for an hour and a half, maybe 2 hours, take a quick 20-minute break. I break the lectures in half, so it gives me a chance to render out the first part of lecture, get it uploaded, so my computer is not trying to deal with 4 hours of video. Laptops are great, but they're really not meant to be workstations. So like I said, use Zoom if you want to. You guys can sign in. You can take screenshots of the lectures. Like I said, I archive this, so this lecture will be up, when we're done. All right, if you cannot make the deadline to deliver stuff to us, do not send it to us in an email. Don't give us a Dropbox link or a OneDrive link. You need to request an exception to turn something in late. That means we will open up FSO again, and you will have up to 3 days to submit it. Doesn't matter what the reason is, poor time management, you lost internet, you lost power. We will go by the timestamp of your template files, meaning when you've got them completed. So if internet goes out, you can't deliver your stuff, well, your stuff is all done already and it's all packaged up. That's what we're worried about. Was it done before the deadline? So if you have any questions, let us know. This is from the activity 2 under the course overview. It's all our policies. So take a look at it. There will be a 10-point deduction each day it's late, unless it is beyond your control, like power, internet, something like that. Storm, not a big deal. We'll work with you. All right, so software you'll need, Maya 2020. We do use 2020, not 2022. There's still a lot of issues with 2022, even the first update. I've got 2022.1. It's much better, but it still crashes too much for my taste to do a live lecture demo. And for our class, 2020.4 works much, much better. It's still Maya, it's still going to crash, but it works better. The Arnold plugin that's required is at least 4.2.1.1. That's pretty old in today's standards. It's about 3 months old. Then the current version, which I went in last night and looked, and on Saturday when I sent the email out, it was 4.2.3. I opened up my computer Sunday, and all of a sudden there's a big happy green bar saying, hey, come get the new version of Arnold. It's 4.2.4. So later on, when we get into doing a demo, I will attempt to update Arnold live, which is always dangerous. But if I have trouble, I'm assuming you're going to have trouble too, so you may as well find out. Photoshop, we're going to use Unreal Engine 4.25.4. That is the approved game art and computer animation version. Everybody's using the same version. I have not heard of any new updates yet. This one is the most stable. We're going to use After Effects, put movies together, and Substance Painter. We're not going to use any of the other Substance products, but Painter, you guys are familiar with. If you haven't gotten the new version from Adobe, it's part of your Creative Cloud. If you open up the Creative Cloud, it should be in there in your account. All right, so this is what I got this morning or last night. It says, oh yeah, new Arnold version 4.2 or 4.3.4 is available. So my version is 4.2.3. It'll work fine, but I always try to keep it updated because honestly, it does make a difference. All right, any questions so far? Make sense? How about out there in the Zoomosphere? Can we update our Macs to Big Sur? I would not recommend that. We have not gotten the official okay from our IT department. Only because there's a bunch of stuff at Full Sail that still hasn't been tested on it. And that's why they're always a little cautious. Now, I have had students, to be honest, full disclosure, I've had students who have had to update because for whatever reason, Adobe Creative Cloud wouldn't work on their previous version. So they've had to update to Big Sur. They didn't explode, which is good, but they did have a lot of trouble getting everything working. So don't update yet. Good question. Because, every month I always ask if we can update. I was like, no, we haven't looked at it yet. Okay. Awesome. Any other questions? Questions out there in the Zoom land? All right, Haley's good. Thank you. Tano's good.
Good.
All right. Thank you, Julio. All right. So file management with Maya and Arnold. In general, you're working for somebody, you're working in a production, you're delivering files to somebody. It's a good idea to avoid putting spaces in your file name and in your folder. Only because folder file name spaces are not universal across all platforms. Linux is not too crazy about it. Windows is pretty tolerant. The Mac is pretty tolerant, although some software inside those operating systems is even less tolerant, like Maya. You notice in Maya, if you try to put a space somewhere in like a display layer or a file name in the outliner, it does not like that. It will automatically put an underscore or, throw up a caution flag. So the safest thing is to use underscores to separate words or use what's called the Camelback style of naming, which means the very first word is lowercase and then each word after that has a capital letter. That is a common Unix workflow file naming convention. All right, no special characters should be in the name at all. Dots especially, dots are only reserved to separate the file name from the extension. If you put a dot in the middle, it will confuse lots of software, including After Effects. After Effects will go, wait, that's not a number. I can't use that as part of a sequence, and it's not a file extension. Hyphens are okay. Underscores are okay. That's about it. Things like colons, backslashes, forward slashes, commas, exclamation points, extremely dangerous if you're in the Unix environment. There's a tilde, there's an asterisk, there is the @ sign, the pound sign, the dollar sign, those are all coding things. %, again, coding the caret. Ampersand, plus, minus, or no, minus is okay because that's a dash, plus, equal, and left parens, right parens. If you have any questions, ask, but don't use those in your file naming. They're usually reserved for coding. Some programs have no problem at all, like Adobe Photoshop doesn't care. You can name it anything you want inside Photoshop. But outside where your OS is, there's the risk right there. Whatever you do, don't ever put a dot in front of any name because that usually means it's a hidden file on most operating systems. Your stuff will all of a sudden disappear and you can't figure out why. You got to go looking for hidden names. Now, file management with Maya and Arnold includes using a project folder structure. You guys know what a project folder structure looks like? What does it look like? Exactly. So your main project is sort of like a little mini folder database. Inside of it, it has little subfolders. When you set your project to the main folder, Maya knows it can get files and save files into that structure. And it's got to be the naming structure that Maya recognizes. Like all your scenes go into the scenes folder. All your renders are going to go into the images folder. All the images that you're going to use as textures and dome light images are going to be done in the source images folder. There's another folder for render data, another folder for movies. So Maya uses all of that information to keep track of files whenever you go to work on it. Now, the reason you need to set your project is because you can take that Maya project folder structure, put it on any computer. As long as it's got Maya, you can put it on Unix or actually Linux, Windows, Mac, you name it. Set your project, open it up, and Maya can find everything because it is a little self-contained package. Now, a lot of common problems happen when people double-click on their scene files. Doesn't matter if you've set your project folder or not. If you double-click on it, you run the risk of breaking the connection. Always open your Maya scene file inside Maya. So launch Maya first, set project, file, set project, find the location, then go file, open scene, find your scene. If you set your project correctly, Maya will take you right to the scenes folder and you will have a choice of all the scenes that are in that project folder. Failure to do that will cause or may cause your renders to fail, your connections to be broken when you're putting textures in. It is a nightmare. And invariably, somebody will forget. And it's not catastrophic. It's just going to take a lot of work to link everything back up. Do it right the first time. You don't have to go back and fix it. So everything we give you is going to be project folder based. Now, the first download that I had for you guys, project1_Arnold, SAL_Arnold, right? That's going to have 3 folders in it. One of them is a Maya project folder. That's what you set your project to. One of them is a template folder where you take your renders, you're going to put them in a template. And the third is going to be a reference folder. That is your target. That's what your stuff should look like. So we're always working with reference in this class. Always. In fact, even when you're creating your own artwork, you always go out and get reference for stuff. It's great to use your imagination, but if you're trying to do something specific, you want to have reference so that you have something concrete you can capture. Make sense? Question? Maya project folder, naming. All right. All right, so term ID for all the submissions is going to be year_month. So for us, it's going to be 2021_09. So anytime you see this in your file naming, you're going to substitute 2021_09. So last name, first name, _project1_01 comp. That's the first exercise. _SAL-C, C campus, O online. Year, 2021 _ month. If you have any questions, let us know. Okay. Now everybody can breathe. Now we can actually get into some rendering. All right. So in order to make a render happen, or even to look at something in the real world, let's just not go as far as rendering. Let's just say to see something in the real world, we need 3 things. Okay, 1, we need something to record the event. Most of the time, your eyes or a camera, if you want to record it and look at it later. Okay, there's one of the components. The second one is you need light. Without light, you're not going to be able to see anything to record it or experience it. Now, it's great to have light, but if light doesn't hit anything, you don't know it's there. So light needs to hit something like a surface, piece of geometry, or an object. Those 3 things make something visible. The world that we look at in this room, in Full Sail, walking down the street, is a result of light hitting a surface, bouncing off that surface, and going into our eyes. Bright sunny day, lots of light, dark inside here in Full Sail. Well, it's a darkened room. We still have a lot of light in here, but a less intense environment. Now, a little bit different for CG, computer graphics, right? We not only need an object, but we also need a material on that object so that the computer knows how to reflect the light. Is it smooth? Is it rough? Is it shiny? Is it dull? Is it transparent? We need that kind of description so that we can basically recognize objects in CG. So we know what glass, we know what metal, we know what plastic, we know what concrete, we know what wood looks like. Does that make sense? So CG or the real world, we need the same tools. Now, that goes for rendering too, not just looking and recording with a camera. And actually, a camera is sort of like a real world render. We're recording it, but really fast. Now, let's talk about rendering, but not in the purely digital electronic sense. Let's talk about rendering in terms of fine art. The term rendering's been around for a long time before computers were even thought of. Artists used to do renderings all the time. So what does it mean when we say, give me a render of this container, my bottle sitting on a table? Yes. Okay, finished drawing. I like that. So finished drawing. What does that mean, though? So what is involved in a finished drawing? What do we mean when we say it's finished, it's done? What makes it done? What makes it look finished? Okay, so shading and lighting, kind of a broad term though. So as an artist, you got a piece of paper, blank piece of paper, we give you a graphite pencil. Doesn't matter how hard or soft it is. And we say, give me a render of this, or give me a drawing of this. What are you going to be capturing? Okay, that's good. I like that. How it interacts with the environment. I'm going to abbreviate that. Okay, so how it interacts with the environment. What are the clues that tell us how it interacts with the environment? Okay, so how light reflects off it. What else? How it feels. Okay. So if we were to look at it, we could go, that concrete looks smooth, or that concrete looks rough. We'd be able to tell that by looking at it. Is that what you're getting at? Okay, good. How it feels. Anything else? So if I put this up here, unfortunately, what else do I have besides that going on? Wherever you have light, what else do you have? Shadows. So shadows are 180 degrees from the light source. That tells us direction. That tells us what kind of light it is, whether that light has really hard edge shadows or it's really soft shadows. Go out, sunshine, no clouds, you got pretty hard shadows on the ground. Go out, no sun, sun's being hidden by clouds, everything is super soft, really hard to see shadows. All right, good. So finished drawing, how it interacts with the environment, how light reflects off it, how does it look, how does it feel if you were to touch it? That's what your render should be able to tell you, and the direction of the light, what kind of light it is. So awesome. So in reality, rendering, simply put, is really light and shadow and how it interacts or reacts to a surface. How does it make the surface look? When we talk about something is smooth or something is rough, We're talking about the very fine, minute shadows that we see on a rough surface, like grains of sand. So, artists have been trying to describe light and shadow and how it reacts to a surface for hundreds of years, if not a couple thousand. Because art's been around since we learned how to pick up something and draw on a cave wall or in the sand. So, a couple of quick examples. 18th century artist Frederick Leighton, that kind of style of art, they were very interested in the folds of the fabric, light and dark. The dark areas are where the shadows are. The light areas are the areas that are being hit by light. If you could describe how fabric folds look and get the viewer to believe it, you are pretty much at the top of your game. That's as hard as any other surface to do, to be able to get that fine detail in there. Now, traditional oil. Go to another medium, like the one on the right. That is the Da Vinci self-portrait done by Albanian mosaic artist Samir Strati. His medium is roughly 500,000 nails to be able to do the Da Vinci portrait. That's, drywall, roofing, copper, zinc, brass, paint it white, paint it gray, paint it black. Didn't matter. As long as it copper, bronze, whatever gave him the look that he wanted. And you can see close up there, him nailing all of the nails into the wall. Yes. Go ahead. Go. Yeah. You can just go. All right. So now, what are each of his nails equivalent to in CG? Pixels. Yep. That's his medium of expression. Pixels. So every time you complain about, oh, so many mouse clicks, you could be hammering your pixels into the side of a very unforgiving wall, getting carpal tunnel and bloody stumpy fingers from smashing your fingers with the hammer. All right, so we can break rendering down in 3D into three main parts. But in the end, no matter which method we're using, whether it happens to be software rendering, hardware rendering, or vectors, we are basically converting our precious polygons into pixels. And usually polygon equals multiple pixels, but not necessarily. So let's try and find out what the difference is between software, hardware, and vector rendering. First off, let's define what they each do. So software rendering implies that a program has to run something in order to make something visible. It's got to take time. Hardware rendering is basically something that may be built into the operating system or built into the application that exists there in real time. Real time being you can interact with it and not have to wait for it to calculate something. Now, obviously, if you're opening a file, you may have to load the file in and be able to read it and to be able to execute it. So there's overlap and crossover there. Now, vectors are kind of unique. Vectors are basically a bunch of numbers that describe an image. So let's start with vectors. Vectors basically points that are graphed, and any curve or straight line based on that is calculated. So the computer draws that curve not as a bunch of little pixels on a screen, but as an arc or as a S-shaped curve, which is very popular. Now, so vectors could be a point here and a point here, and it could be a straight line between it, or it could be a curve like this, a better curve like that, or in the case of something like a Bezier curve, you've got little handles on the points on the end that help to control where the curve is going. So instead of just having a single curve or a single arc, you can take it and make that curve bend into like an S-shaped, more organic curve. So basically you're getting two curves for 2 points rather than having to do two separate curves like that. So these little handles help us define where that curve direction is going. Now, can anybody think of any programs that use something like this?
Maya.
Maya, okay. Maya uses the CV curve, right? Any other apps? Yeah, well, Blender has it, yep. How about non-3D? Doesn't have to be 3D. But Photoshop, yes and no. Only because Photoshop is really a raster-based, meaning pixels rather than curves. They do have paths and things like that, but it's really not the same as its sister application. Illustrator, yes, Adobe Illustrator. Or Corel Draw, Unreal's got it, Unity's got it also. You have the ability to make vectors. Nice thing about vectors is you can scale them up to be as big as a building or shrink them down to like the head of a pin and not lose resolution because it is all math-based calculation. Good. All right, so let's go tackle software. Software rendering. Basically, software, you have to wait. Something's got to calculate before it's displayed. Substance? Well, Substance is, I would say yes. Substance would be kind of software and hardware, because in the Substance viewport, it'll give you a really good rough idea, but then if you want to render it out, you go over to the iRay section, and then you got to wait for it to do all the iterations. But yes, Substance, I would say, would be this and also this, because that Substance viewport is not wait and see. It's, I put something on, I can see it right away. You know, and you're constantly moving that light around to see what does my reflection look like? How does my speck look? How does my metallic look? How does my roughness look? All right, other software. So Haley said Unreal. I would say yes, Unreal would also be part of software because Unreal does have the ability, besides being real time, to actually render stuff out. Yes. Well, when you're done and you render a movie out, yes, if that's what you're referring to. Because basically you're really taking multiple frames that have been put together and trying to make them into a self-contained player. So yeah, you are rendering it kind of, but the hard work's already been done. You're just taking all those sequences and then putting them together so they play continuously. But yeah, sort of. After Effects. How about Maya? Maya's got a software renderer. How about Arnold? How about Blender Cycles? How about RenderMan? How about V-Ray? All examples of software rendering. Click a button, gotta wait for it to go through and sample, cycle, update, clean up, make presentable. All right, how about hardware? Yeah, well, Maya's got hardware. Maya's viewport is actually considered hardware rendering. I mean, it's not the greatest, not nearly as elegant as Unreal or Unity, but you model in it. You want to go into shaded mode from wireframe, you do that, that's pretty much hardware. So yeah, absolutely Maya. Pretty much any one of these up here, except for After Effects. Well, I take that back. You wouldn't have cycles, you would have Eevee in Blender instead, which is their real-time version. RenderMan, they're not quite up to real-time. V-Ray has a plugin for Unreal, but it's still based in Unreal. So Unreal, Unity, pretty much the same cast of characters. And one we forgot about, CAD, computer aided design. So we came up with a much more extensive list than I've got here, but they're all valid. All right, so software rendering occurs on the CPU for the most part, not restricted to the graphics card. Produces very high quality images. Why? Because we have the luxury of waiting and time. Generally more flexible, but more time consuming. We've got hardware rendering, occurs mostly on the GPU, although not restricted. Modern game engines utilize GPU, CPU, all available memory. Typically produces lower quality images, but that is changing very rapidly. We've got things like RTX graphics cards that can render in real-time ray tracing in Unreal. A lot of games are now being upgraded to be able to use that. Definitely faster than software. A lot of times, though, you do have limitations on things like lights and shadows. Now, the reason you do that is because you are trying to run something in real time, meaning immediately. And for example, let's use our room here, our classroom. we've got a lot of lights around the perimeter of the room in the ceiling. Those lights, for the most part, are static. We are not interacting with them, causing them to cast a shadow, unless I get up and I put my hand on the wall. And now I am interacting with those lights. So now they are dynamic. But when I move my hand away and sit back down, they're static. So a lot of times with gaming, we pre-bake our lighting, meaning we kind of bake it in, we calculate it, so we don't have to calculate it all the time. It's pre-calculated, meaning it is part of either the textures or it's built into the memory, so you can go around that environment, not have to worry about the light changing. It's going to be the same. However, you put a character that interacts with the light, now all of a sudden it's dynamic and you got to rebake that part. But it's much faster than having all these lights on, calculating their position for every single frame. Shadow support. There are times when you've got a bare light bulb. A bare light bulb will shine pretty much in all directions. In the real world, that light bulb is going to cast a shadow in every direction. In gaming, we don't want to calculate casting a shadow in all directions. Only the shadow direction it's going to matter, where a character or an object interacts with it. Does that make sense? Questions? So we try to be as efficient as possible. Now, area lights are a little more expensive. They're fairly new within the last 5 to 10 years in gaming. And that's only because computers have gotten better at calculating. Gaming cards or, graphics cards have gotten better. Not necessarily gaming. There are workstation cards that do the same thing. But the thing about area lights is they're what we call our physical light, meaning when we change them, we make them smaller or bigger, they change how they behave. They change the look. We make a light really big, it tends to make the light behave softly. So example, I'm going up to the board now. Example would be if I'm standing here in front of the projector, it's almost like a direct spotlight. I have a shadow on my hand that is really pretty hard. The edge of it is very defined. But as my hand goes further away from the backdrop and closer to the light, what's starting to happen to the shadow? It gets fuzzier or softer. Now, the light hasn't changed size, but my location relative to the light has. It's gotten closer. So when you have a light that's closer to an object, or you make it bigger, it creates a soft shadow. Whereas if you have a light that's small or far away, you have a harder shadow. And that's what area lights do, but that's expensive. So a lot of times we don't use them in gaming unless it's for a very special purpose. All right, so that was a quick demo. I don't think I can do that on the wall here effectively to demo for you guys. Sorry about that. All right, so vector rendering. Maya has a vector renderer. You have to use Maya materials though. You can't use Arnold, can't use anybody else. But it does give you the ability to do line art, toon shading, wireframe, which is really nice. It's got a special little feature in there. So if you're a modeler and you want to show off your mesh, you can have it render out the wireframe mesh. Now, it'll give you formats like the old Shockwave, AI, Illustrator. You can take stuff out of Illustrator, bring it into Maya, take it out of Maya, bring it into Illustrator. Encapsulated PostScript. Nobody really uses that unless you're going to print. And then the real big feature, though, is scalable vector graphics, SVGs. They're the things that we see on the internet where you can zoom in and the resolution doesn't get worse. It gets better, you know, it stays the same. You zoom out, it stays the same. So all based on math plot points. All right, so in the world of software rendering, that's where we're going to spend most of our time, we are going to go into Unreal and do an exercise in Unreal in lecture 4, project 4. Now, Maya software, which is pretty much what most renderers are based off of in some manner. Built into Maya, older technology. It started out life as what's called a scanline renderer, which meant it displayed pixel by pixel, line by line, row by row. When it was done a pixel, it drew it on the screen. As opposed to ray tracing, which ray tracing will calculate each pixel with a ray shot out of the camera or the light. Depends on the kind of ray tracing you're doing, which tends to make it a little more accurate, where when you're calculating something from the point of a pixel, it goes into your environment. If it interacts with other surfaces, it'll either bounce off of it, go through it, it'll just keep bouncing around. But that was always layered on top of scanline. So Maya was never really built as a ray trace renderer. That's why Maya has always included a third-party renderer. Before Arnold came along, they were using something called Mental Ray, which was NVIDIA, until NVIDIA kind of gutted it and just said, we're going real time, forget all this other stuff. But the thing that Maya had from the very beginning, which was really unique, was this thing called IPR, interactive photorealistic rendering. Basically update your pixels on the fly to allow you to see changes that were made. Now, all modern renderers have this. You guys know when you were working in Arnold, or no, working in Substance, if you were in iRay rendering and you change the angle of your camera, it would update again. Now, it all works really well, and the whole principle behind it is constantly updating the scene. But the problem was, in the early days of IPR rendering, memory would fill up on a computer and it would just stop working. That still happens occasionally. So if you are working and your stuff is not updating, stop the renderer, close the render view, open it again, and kick off another render. That means you probably filled up some memory block somewhere, or Maya's about ready to crash, or Arnold is being Arnold attached to Maya. All right, Arnold started off life way back 1997, solid angle. The modern version that we see was co-developed with Sony ImageWorks in 2004. And it's been updated since then. So we're coming up on almost 20 years. We got 17 years of Arnold. And it's been used by a lot of different places. There are plugins for Maya, 3D Max, Houdini, Cinema, Katana. It uses what is called a Monte Carlo ray tracing renderer. Now, all that means is that it creates randomized sampling of points each pass it makes. So you guys are familiar with Substance, right? When you go to render something in Substance using iRay, it has iterations where it looks really grainy, and then the next wave it looks a little better, and it keeps getting better each pass of sampling. Well, that's kind of what's going on. Those sample points are randomly chosen, and then they're re-randomized and shot out again. So in theory, you will get a lot of points that don't overlap, but you'll get some points that do overlap. And you keep doing that randomly, shooting points out in the scene. So it covers it a lot more than if you just send it out in one location. Does that kind of make sense? Questions? All right, so Arnold, path tracing, global illumination, caustics, image-based lighting, all those things, all modern renderers do, but Maya can't do it because it's just not meant to. That's why Autodesk bought Solid Angle and incorporated into Maya. All right, so in the end, doesn't matter what 3D package you're using, you're taking your three-dimensional, really nice looking scene, and you are flattening it out into a two-dimensional render. Yes, we have stereo cameras. Yes, we have stereo glasses. We have 3D glasses. We have virtual reality. But in reality, pun intended, you still got little screens in front of your face. Even with a headset, a VR headset. You still got little screens. The timing's a little bit off and the position is off based on your eyes. The way we see, it's still basically two dimensions for an image or an image sequence. We're still flattening it out. So, purpose of rendering, we want to produce the highest quality image for the least amount of time to meet the production deadline. Now, that production deadline, that could be anything. Could be your assignments due. It could be a movie, a game you're working on, a cinematic, doesn't matter. We're still describing light and shadow and how it reacts to a surface. So a couple quick examples of rendering. Here's old-fashioned scanline rendering. This is before ray tracing, where objects were treated as either transparent or non-transparent, but the shadows were treated as maps. Nothing went through anything. There was no reflections. All right, fast forward a little bit. We have ray tracing. Ray tracing generally samples one ray per pixel, meaning that ray hits the pixel, that's it. Displays better reflections, refractions, transparent shadows, other advanced forms. You get into path tracing, and path tracing will sample one pixel with multiple rays, which means we get it from all different angles where rays are looking at pixels next to it, as well as the pixel that it hits, and calculating a much broader picture. Now, the nice thing about path tracing is it is only concerned by what the camera can see. Once a ray goes outside of the camera, it doesn't care. It's much more efficient than just ray tracing the entire scene. It does take more time to render. All right. Questions? This is a pretty good time to take a break. Been at it an hour and a half. It's good for me to clear my computer. I'll tell you what, let's come back at, let's see, come back at 2:55. We'll take a quick break. I do have to end the session so that I can render out this part of lecture. I will lock the room up so you guys can go out, take a break. I like to go out and take my mask off, let it dry out, get some air, get a drink of water. Anybody have any questions? Yes. Sure. Right there. Yep, no problem. And I'll probably show it again, recap it when we come back. So no worries about that. You do? Well, yeah, it looks different. It's got darker edges to it because there's not quite as much bouncing of light and the way it handles it. But yeah, I mean, it's kind of it's a look, it's a style. All right, guys, I will see you back here at 2:55. And like I said, I need to end the session so I can render out the first part of lecture, upload it, and then when we start, I'll restart recording the second half of lecture.